Imagine a world so strange yet so fascinating that its surface might actually sparkle with diamonds. A planet where temperatures are hotter than anything we can imagine, and the skies are filled with fire. This is 55 Cancri E, a place often called the Diamond Planet. But is this world a cosmic treasure chest or an uninhabitable inferno? Let's dive into what makes it so unique. Cancri E is located about 40 light-years away from us in the constellation of Cancer. It was discovered in 2004 and is what scientists call a super-Earth, a planet larger than Earth, but smaller than gas giants like Neptune. What makes it so fascinating is how close it is to its parent star. It's so close, in fact, that a single year on 55 Cancri E lasts just 18 hours. That means the planet whizzes around its star at an incredible speed, locked in a position where one side always faces the star and the other side is in permanent darkness. Temperatures on the sunny side can soar to over 2,400 degrees Fahrenheit, making it one of the hottest exoplanets we've discovered so far. The reason people call it the Diamond Planet comes down to its chemistry. Scientists believe its interior might be rich in carbon. If conditions during the planet's formation were just right, the immense pressure inside could have turned some of that carbon into diamonds. In fact, some estimates suggest that a third of the planet's mass could be diamond. Think about that for a moment. A world so filled with this precious gemstone that it would put every diamond on Earth to shame. It's a dazzling idea, but the reality of this planet is far from glamorous. Unlike Earth, which has an atmosphere that supports life, 55 Cancri E's atmosphere is likely filled with toxic gases like hydrogen cyanide and methane. These gases, combined with the searing heat and radiation from the nearby star, make it a brutal place. Imagine standing on a surface hot enough to melt metal, with volcanoes potentially erupting across the landscape, and no night to offer relief from the constant glare of its star. It's not exactly a paradise, despite its glittering nickname. Still, there's something incredible about this planet. It challenges our understanding of how planets form and what might be possible in the universe. Could other planets like this exist? Could they really have surfaces sparkling with diamonds, or is that just a scientific metaphor? What do you think? Does 55 Cancri E sound like a sparkling wonder or a glittering nightmare? Let us know in the comments below. In the next section, we'll explore its fiery landscape in more detail and ask the big question: could life, even in its most extreme forms, ever survive on this alien world? Stay tuned. Could a planet as dazzling as 55 Cancri E actually be a fiery inferno hiding a dark secret? While its reputation as a diamond planet might sound glamorous, the reality of standing on its surface, if you could somehow survive, would be a nightmarish experience. The conditions on 55 Cancri E are some of the most extreme in the universe, making it a fascinating yet terrifying place to imagine. First, let's talk about the heat. On the side of the planet that constantly faces its star, temperatures reach an almost unimaginable 2,400 degrees Fahrenheit, 1,300 degrees Celsius. That's hot enough to melt most metals and reduce rock to liquid. Scientists believe this side of the planet might be covered in vast oceans of molten lava, glowing red and orange like an unbroken sea of fire. The air above this blazing surface would shimmer with heat, distorting any view and making the very idea of standing there utterly impossible. And let's not forget, there's no nightfall to bring relief. The same side of the planet always faces the star, trapped in eternal daylight. Meanwhile, the dark side might be significantly cooler, though still far too hostile for any form of life we know. The atmosphere adds another layer of chaos to this hellish world. Observations suggest that the air surrounding 55 Cancri E is filled with toxic gases like hydrogen cyanide, which is deadly to humans, along with methane and possibly carbon monoxide. The extreme temperature difference between the day and night sides likely creates violent winds that rip across the surface. Imagine hurricane-force storms carrying heat and toxic chemicals across an already volcanic landscape. It's a scene straight out of science fiction, but it's very real. So, how do scientists study a place like this? Clearly, no spacecraft is going to land there anytime soon. Instead, they rely on telescopes and computer models to simulate the conditions on 55 Cancri E. Using instruments like the Hubble Space Telescope and others, scientists analyze the light coming from the planet and its star. The way this light changes as it passes through the planet's atmosphere gives us clues about its chemical makeup. To test their theories, researchers replicate these extreme conditions in high-pressure labs on Earth, using powerful equipment to mimic the heat and pressure found on 55 Cancri E. It's through these experiments that they've begun to unravel the mysteries of its molten surface and toxic skies. If you were to somehow stand on 55 Cancri E, protected by an impossible suit of technology, of course, it would be an utterly alien experience. The ground beneath your feet might be a shifting, glowing mass of liquid rock, the air thick and shimmering with toxic gases. The light from its nearby star would blaze unrelentingly, casting sharp, dramatic shadows across the molten landscape. The heat would be so intense that even the strongest materials we know on Earth would quickly break down. It's a world so hostile, it's almost poetic in its danger and beauty. What do you think? Could you imagine a planet so extreme it feels like the universe's own version of hell? And yet, there's something awe-inspiring about it, isn't there? Let us know your thoughts in the comments. Next, we'll dive into one of the most intriguing questions about 55 Cancri E. Could life, no matter how strange, possibly exist in a place like this? Stay tuned! What if 55 Cancri E isn't the treasure trove we imagine? Could this glittering diamond planet actually be fool's gold? While the idea of a world filled with shimmering diamonds sounds extraordinary, the science behind this claim is more complex and far less certain than you might think. Let's unravel the mystery of this so-called treasure chest in the stars. The diamond planet theory originates from the idea that 55 Cancri E might have formed in a carbon-rich environment. Unlike Earth, which formed in a region of the solar system with abundant oxygen, 55 Cancri E's parent star is thought to have a higher proportion of carbon. This abundance of carbon could mean that the planet's interior contains vast amounts of graphite or diamond, compressed under immense pressure. Early models suggested that the intense heat and pressure within the planet could have transformed much of this carbon into solid diamond, potentially making up a significant portion of the planet's mass. It's a dazzling idea, an entire world glittering beneath its fiery surface. But how do scientists arrive at such conclusions when 55 Cancri E is located 40 light-years away? The answer lies in spectroscopy, a technique that analyzes the light coming from the planet and its star. When light passes through the planet's atmosphere or reflects off its surface, it carries subtle signatures of the elements and molecules present. By studying these patterns, astronomers can estimate the planet's composition. In the case of 55 Cancri E, this analysis hinted at the presence of carbon-rich compounds, leading to the diamond hypothesis. However, as tempting as it is to imagine a planet covered in precious gemstones, not all scientists are convinced. More recent studies have cast doubt on the diamond theory, suggesting that the planet's composition might be far more ordinary. Instead of diamonds, 55 Cancri E could simply have a rocky surface with a thin layer of atmosphere. One of the biggest, Challenges in studying exoplanets is the limited data we have. With technology improving all the time, future observations could either confirm or completely debunk the idea of a diamond-filled core. Even if 55 Cancri E isn't a literal treasure trove, the possibility of carbon-based worlds raises fascinating questions. Could there be other planets in the universe where diamonds are as common as dirt on Earth? And what would such a planet look like? Would its surface shine in the starlight, or would its diamond core remain hidden beneath layers of molten rock? It's a humbling reminder of how much we still have to learn. What do you think? Is 55 Cancri E the glittering jewel of the cosmos, or just another rocky planet with a glamorous nickname? Share your thoughts below. Coming up, we'll explore whether life, in its strangest and most resilient forms, could find a way to survive on this extreme and mysterious world. Stay tuned. If life can survive on Earth in boiling acid, deep under the ocean in volcanic vents, or frozen beneath miles of Antarctic ice, could a world as extreme as 55 Cancri E have its own alien survivors? While 55 Cancri E might seem like the ultimate definition of hostile, the universe has a way of surprising us, and so does life. On Earth, we've discovered organisms called extremophiles that thrive in conditions that, at first glance, seem utterly incompatible with survival. In the crushing depths of the ocean, where no sunlight ever reaches, microbes live around hydrothermal vents, drawing energy from chemicals spewing out of the Earth's crust. In Yellowstone's acidic hot springs, where water bubbles at temperatures well above boiling, brightly colored bacteria thrive in pools that would dissolve human flesh. Even in Antarctica, where temperatures plunge below 100 degrees and sunlight disappears for months, microbes have been found beneath layers of ice, surviving on nothing but trace amounts of water and nutrients. These creatures redefine what it means to be alive and push the boundaries of what we once thought possible. Could something similar exist on 55 Cancri E? To survive on a planet where temperatures can melt rock, life as we know it would need to be almost unrecognizably different. The iod, extreme heat, radiation, and toxic gases like hydrogen cyanide would make it impossible for Earth-like life to exist. But what about life as we don't know it? Scientists have speculated that alien microbes might evolve mechanisms to adapt to intense heat, using chemical processes entirely unlike anything we've seen on Earth. Instead of relying on water, which would vaporize instantly on 55 Cancri E's sunlit side, these organisms might use molten rock as a medium or extract energy directly from the planet's lava oceans. Another possibility lies in the dark side of the planet, where temperatures are far lower. While the contrast between the scorching day side and cooler night side likely creates chaotic winds and storms, there might be regions in the twilight zone, where day meets night, that are slightly more stable. If life could find a way to anchor itself in this narrow strip, it might exist in a form we can't yet imagine. What if microbes lived in the turbulent atmosphere, drifting through clouds of toxic gas and feeding on chemical energy instead of sunlight? It's not impossible, and in a universe as vast as ours, stranger things are bound to exist. Of course, this is all speculation, and the chances of life on 55 Cancri E are slim at best. But the idea that even the most extreme worlds might harbor some form of life is what drives scientists to keep searching. If we've learned anything from Earth's extremophiles, it's that life can find a way to persist in the most surprising places. So, could 55 Cancri E have its own alien survivors? It's a thrilling possibility, one that reminds us of just how little we know about the universe and the incredible adaptability of life. What do you think? Could life, no matter how bizarre, find a way to exist on such a fiery, hostile world? Let us know your thoughts in the comments. And next, we'll wrap up by reflecting on what planets like 55 Cancri E tell us about the diversity of worlds in the universe and our own search for meaning among the stars. Stay tuned! From light curves to spectral fingerprints, we've developed incredible tools to study distant worlds. But when it comes to answering the big question, are we alone in the universe? How close are we, really? Planets like 55 Cancri may be tens of trillions of miles away, but thanks to groundbreaking technology, we're starting to unlock their secrets. Let's take a closer look at how we study such distant and mysterious worlds. When you hear that scientists have determined the temperature, composition, or even the potential atmosphere of a planet located 40 light-years away, it sounds almost magical. But it all starts with light, the faint signals that a distant planet reflects or emits. One key method astronomers use is called the transit method. This happens when a planet passes in front of its star as seen from Earth. When this transit occurs, the planet blocks a tiny fraction of the star's light, creating a dip in brightness. By carefully analyzing these light curves, scientists can calculate the planet's size, orbit, and even how close it is to its star. For a world like 55 Cancri E, this method tells us that it orbits extremely close to its star, completing a full year in just 18 hours. But studying a planet's size and orbit is just the beginning. To figure out its composition, scientists turn to a technique called spectroscopy. When starlight passes through a planet's atmosphere or reflects off its surface, the light interacts with molecules and atoms, leaving behind a unique fingerprint. These spectral fingerprints allow astronomers to determine the elements present on a planet, whether it's rich in carbon or filled with toxic gases like methane and hydrogen cyanide. In the case of 55 Cancri E, spectroscopy has hinted at a carbon-rich environment, which is why scientists once hypothesized it could be a diamond planet. But here's the thing: studying distant planets isn't easy. The light signals are faint, and often overwhelmed by the glare of the star itself. It's like trying to spot a firefly next to a spotlight from thousands of miles away. Astronomers rely on incredibly sensitive instruments, like the James Webb Space Telescope, to tease out these delicate signals. Even then, the data is limited. The farther a planet is, the harder it is to get a clear picture. For 55 Cancri E, which orbits so close to its star, the intense heat and radiation further complicate our ability to gather precise measurements. Despite these challenges, scientists are constantly improving their tools. Advances in adaptive optics, more powerful telescopes, and even ideas for future missions to directly image exoplanets bring us closer to understanding these distant worlds. With every new discovery, we refine our techniques, sharpening the lens through which we view the universe. The study of exoplanets like 55 Cancri E reminds us of the incredible ingenuity of human exploration. We may be separated from these worlds by unfathomable distances, but the light they send us carries answers to questions we've been asking for centuries. Are there other worlds like ours? Could life exist out there in forms we've yet to imagine? What do you think? Are we on the brink of finding life on other planets? Or do we still have a long way to go? Let us know your thoughts below. And as we wrap up, let's reflect on what these discoveries teach us, not just about the universe, but about our place within it. Stay tuned for the final chapter. Would we risk exploring a world that could literally vaporize us, just for the chance of unimaginable riches? Imagine the sheer audacity it would take to send humans to 55 Cancri E, a planet so extreme that even stepping onto its surface seems like a death sentence. Yet, with the promise of diamonds, energy, and scientific discovery, the idea is undeniably tempting. What would it take for humanity to survive, let alone thrive, on a planet this hostile? In this hypothetical future, technology would need to advance far beyond anything we currently have. For starters, just getting to 55 Cancri E is a monumental challenge. At 40 light-years away, even the fastest spacecraft we can imagine would take thousands of years to reach it. To make the journey feasible, we'd need technologies like warp drives, generational starships, or perhaps even the ability to manipulate space-time itself. But let's say we overcome that hurdle and arrive at this fiery world. The real challenge begins on the surface. Landing on 55 Cancri E would be like touching down on the edge of hell. The daytime temperatures are hot enough to melt most materials, so any spacecraft or base would need to be made of heat-resistant alloys beyond anything we've engineered. A human colony might have to avoid the planet's dayside entirely, establishing itself in the cooler, darker regions. Even there, survival would require shielding against toxic gases and the relentless winds that whip across the planet due to its extreme temperature differences. Imagine a colony built like a fortress, with thick domes made of advanced ceramics, or graphene, capable of withstanding both the heat and the crushing winds. But why would we risk all this? One possibility is mining. If the diamond planet theory holds true, the wealth hidden beneath 55 Cancri E's surface would be enough to fund generations of exploration. Mining operations might involve autonomous robots or drones, capable of surviving where humans cannot. These machines could dig deep into the planet's molten crust, extracting diamonds or rare minerals while keeping human colonists safely out of harm's way. Alternatively, we might focus on harnessing the planet's energy. The lava oceans and extreme heat could provide a nearly unlimited source of geothermal power, which could potentially fuel entire civilizations. Still, the idea of humans themselves walking on the surface seems far-fetched. Perhaps we'd rely on remote exploration instead, sending AI-powered probes to study the planet up close, while we observe from the relative safety of orbiting stations. But let's imagine for a moment what it might look like if humans did find a way to walk on this world. They'd need suits far more advanced than anything we've ever designed, capable of withstanding searing temperatures and filtering toxic gases. The surface might be a surreal landscape of glowing molten rock, with the intense light from its nearby star casting sharp, eerie shadows. Every step would be a battle against the environment, a reminder that, despite all our ingenuity, we are fragile creatures in the vast, unforgiving universe. So, could we ever truly colonize 55 feet Cancri E? The answer might lie not in colonization, but in observation and exploitation from a safe distance. This world may not be a place for human settlers, but it could become a hub for robotic exploration, a resource for energy or minerals, or even a proving ground for technologies that could one day take us to even more extreme worlds. What do you think? Would humanity be bold or reckless enough to attempt such a mission? And even if we succeeded, would the rewards outweigh the risks? Let us know in the comments below. As we wrap up this journey to 55 Cancri E, let's reflect on what this fiery, mysterious world teaches us about the potential and the limits of human ambition. Stay tuned for the conclusion. As we reach for the stars, 55 Cancri E reminds us that the universe is as deadly as it is beautiful. It's a world of extremes, a fiery furnace where temperatures soar, toxic gases swirl, and molten lava flows like rivers. Yet, even in such an inhospitable place, we can't help but wonder, could life, in some form, exist there? Or does this diamond planet serve as a stunning reminder of the limits of life as we know it? When we piece together everything we've learned, it becomes clear that 55 Cancri E is an enigma. Its carbon-rich composition and extreme environment highlight just how diverse planets can be. Unlike Earth, with its temperate climates and life-sustaining atmosphere, 55 Cancri E is locked in a brutal dance with its parent star, enduring relentless heat and radiation. The idea of it being a literal treasure trove of diamonds is captivating, but even if it is, its riches are locked away beneath an inferno. For now, the likelihood of life, as we know it on 55 Cancri E, seems impossibly small. The heat alone would annihilate any Earth-like organism before it could even attempt survival. Still, studying this planet isn't just about searching for life. It's about expanding our understanding of the universe. 55 Cancri E is a window into the wild variety of planetary systems that exist. Its extreme conditions challenge us to think beyond Earth-centric ideas of habitability. Could life elsewhere take on forms we've never imagined, thriving in environments far harsher than anything on our planet? By exploring worlds like 55 Cancri E, we're not just looking for alien microbes, we're broadening the scope of what life could mean. Moreover, planets like 55 Cancri E bring us closer to finding Earth 2.0, a world that might not just support life, but mirror our own. For every uninhabitable furnace like 55 Cancri E, there may be another planet perfectly balanced, orbiting its star in the habitable zone where liquid water can exist. By studying extreme planets, we refine the tools and techniques needed to identify those rare gems in the vastness of space. Spectroscopy, light curves, and advanced telescopes like the James Webb Space Telescope aren't just helping us understand 55 Cancri E. They're paving the way for discoveries that could change humanity's place in the cosmos forever. So, what does 55 Cancri E truly teach us? It's a reminder that the universe is as diverse as it is unforgiving, filled with planets that defy our expectations. But it also shows us the power of human curiosity and our relentless drive to explore, even when the odds seem impossible. One day, we may find life where we least expect it. And when that moment comes, it will redefine everything we know about existence. What do you think? Does 55 Cancri E inspire hope for discovering alien life? Or does it serve as a cautionary tale about the harsh realities of the cosmos? Share your thoughts in the comments below. And if this journey through the universe's extremes fascinated you, be sure to like this video and subscribe for more explorations into the wonders of space. Until next time, keep looking up and dreaming big.